All right, so we're going to do a little polyatomic ion and solubility quiz. This is practice. Please try to do this though with me. Do it on a piece of paper and do the best you can, okay? So I'm going to give you about 5 minutes. Try not to cheat. Show me what you know. Write down, please write it down on something. Write down 4 formulas and 4 names of some polyatomic ions, okay? Do the best you can. Guess if you have to. See how close you get right now. The worst case scenario, you don't do well, and that's that. So give it a shot. See what you got. Of you. This is good. I want you to know how I'm going to grade this as you're kind of finishing up. Again, if you're looking at it, that doesn't help you out. If you miss one letter or one number, you're still going to get some points. But if you think carbonate doesn't have carbon in it, you probably aren't going to get any. So, give you about 30 more seconds. Again, I can't see any of your screens. You've all locked me out. I am also recording this. I know some of your friends aren't here tonight because soccer and other things too. So, okay, I'm gonna go through it. Grade yourself. I'll give you an idea. So let me give you the first one. And that's not working. There we go. So, carbonate, CO3 2-. So if you had CO4 2-, CO2 2-, that would be a half. Or if you have CO3 1-, or CO3 3-, or something like that. But we talked about this last week. You should at least be able to say the element and an O, right? And then your job is to figure out how many O's there are and what the charge is. So that one you might have to work on a little bit. All right, nitrite, NO2 with a -1. Ammonium, the only one that is positive. This one you just have the pure memorization. NH4+. And then I thought I'd throw in a very dirty one. This one's tough. So I just wanted to throw that out there. I might throw one out there. I'm not trying to penalize you, but just want to see. You know it. If any of you got that, bravo. Usually people don't have that at this point. So if you're like, I had no idea, fair enough. C2O4 2-. Then we go into names. Naming, to me, you got a pretty good shot at it. You're going to say, like the next one, sol, and then it's going to be I or H, right? So you just got to kind of know. If you see a 4, it's pretty good idea that it's an 8. So that's sulfate. OH- is hydroxide. ClO4-, that's hard because ClOs, there's 4 of them. So that is actually perchlorate. If you wrote chlorate, I'd give you a half. And then the last one, I don't know what that is. Well, it's bromine and there's oxygen. So it's bromate or it's bromite. Give it a shot. And it's bromate. So, again, on that one, I would give you 8 points. You get a half. You miss an 8, you put an 8, something like that, it'd be a half. If you have a number wrong, it'd be half. Okay? All right, this other one. And we might have to write on the board, on my whiteboard here, my iPad. But I want to give you a taste, I promise this, of solubility rules. So, let me actually jump here. Okay, solubility rules are about double replacement reactions. they look a lot like this. So let me get a new sheet. So if I were to write this one out right here, okay? So you have N. I miss writing in front of kids on a whiteboard. That is amazing. All right. So you have NaCl, and that's aqueous. Translation: it dissolves in water. And this is AQ. I'll show it to you on the screen later. But what I would do is give you the first two halves of that, and then you have to come up with the products and whether or not it's AQ or if it's a solid. Again, I hope you're seeing my screen. I'm not even sure. It's weird. I'm all by myself here. So here, let's talk about what you need to do, guys. First, I'm not acting like this is overly complicated, but you haven't seen this in a while, so it's important and it's fair to you to make sure that we're going through this. These front, which we call cations, or these anions, they need to switch partners. But you can't switch them front with the front or back to the back. So let me just give you an example. These two are going to switch places. Okay? So now I have, let's just say PB, but now it's with the Cl. And now it's Na, and now it's with the NO3. Okay? Then, every time you make a new compound, you need to check the charges. It's not as hard as it sounds. Reverse cross. So just as a quick review, when you look at a periodic table, it actually wasn't that bad. This is always plus, whoa, that's always +1, +2, right? On the other side, this is nothing. And then it's -1, -2. Remember, we counted that way. So if you don't see anything, you got to look one of these up. This is +1, -1. Because this 2 is here, this is a +2. And then you'd have to know a little something about that. Or because there was nothing here, it's a -1. Why is that a big deal? Because now you got to come over here and go, okay, well, that's +1, -1. It's a +2, minus. Oh, okay. So I have a PbCl2. I would love to go over this. I'm just trying to give this to you very early in the summer so you guys have a whole month to practice this. All right, what's the point now? Where did these go? That's the point. So, I don't have it here. I have on your modules a helpful sheet that's the solubility rules. And if I can give you one huge piece of advice, you don't memorize it all. Know this, the first 3 rules. And the first one is alkali metals. Actually, the first one's nitrates. Nitrates and alkali metals, which is group 1, are always AQ. So right there, here's an alkali metal and here's a nitrate. So this has to be AQ. So if you're gonna guess, this would be the solid. Okay? But I'm going to show you why that is in a second. This is very cumbersome and I'm so sorry. Back to presentation. So here's your solubility rules right here. Hope you're seeing this. Again, I'm assuming because I'm not hearing anything. Nitrates are always soluble. All alkali metals are always soluble, so the elements in the first row. And then, if you just memorize this last one right here, all halogens are soluble except Ag and Pb. Well, if you look at what we just did, it was PbCl2. So Pb is not soluble, so that's an exception. So that would have to be my solid. So that would be an S, right? And then you'd have to balance it. So what I'd like you to do, you might be very confused, you might not be, but quickly try to predict the 2 products of each of these next 2. And then we'll go through them, okay? And I will write them down on my other sheet here so we can do this a little bit faster. Okay, I'll give you a moment to try. Oh, that's it. the rest of this is going to go smooth. Maybe. Again, I don't expect that you guys are going to be necessarily having this perfect yet. Alright, I'm just going to jump into this. So, again, shout out if you're not understanding what I'm saying. You don't have to feel embarrassed about it. Oh my gosh, we just started this stuff. Okay, so here's the next two. Okay, so I gotta switch these. Okay, so there's no rule where I have to put it. Oh my god, do I have two NO3s? Okay, we gotta cheat. Oh, what did I want? I think I wanted an SO4 here. Pretend, I'm sorry. So it'd be Li2 SO4. There can't be two NO3s, that doesn't make sense. So it'd be Ba SO4 and it'd be LiNO3. Okay? Alright. Because both of these, you always go to the nitrates and the alkali metals. I'm not trying to pull punches. This is about as hard as it gets with a lot of this. This has to be AQ. Because of the fact that they're alkali metals and they're nitrates. Okay. If you have to guess the fact that you know that that's AQ, then this must be a solid. You might not be right, but if it says there's a reaction, you have to have a solid made. If you look, you can look later. I'm not going to keep jumping back and forth because apparently it's not working well. Sulfates are soluble except, and there's 4 of them. And one of them is BaSO4, so you might have to study that a little bit. It's called the note card. And again, you might have to balance this, so there's a 2 there in Li, so I want to put a 2 there. And then that 2 with the NO3 makes 2 with the NO3. Final one, just to quickly do this. So there's 2 parts to this that I'm helping you with. One, how do you make new formulas? So switch these. Na, now it goes with the NO3. K, now it goes with the SO4. Every time you make a new compound, you got to check the charges. That's a 1 and a 1 and a 1 and a 2. So the 2's got to come down. Okay. I'm going to say this one's easy. This is why. You have, what is that? I don't even know what that is. Erase. Okay, that's going to do that now. Bunch of comical errors here. You have a nitrate, alkali metal, and a nitrate, and an alkali metal. If you have alkali metals, automatically AQ and AQ. So reminder from last year, whenever you took Chem last, if you have 2 AQs, that is a no reaction. So this is how I could quiz you. I won't make you start from scratch. It'll be something where you have a double replacement reaction. Can you give me the 2 new products? And then just tell me AQ and S. And usually the AQ is really easy to find. It's gonna have an NO3 or an alkali metal in it. And then a lot of times students just kind of guess, well, the other one must be a solid. Okay, so that's that. I'm going to jump back out of here, and then we're going to get into our notes, and I might have to jump and skip a couple things, but I will hit the main stuff for you. And again, please tell me if you're not seeing this presentation in a second, because that would just be heartbreaking. So that's the sheet in front of you right now. I'm thinking you're seeing it, that you should print off or start studying off of. So you got the polyatomic ions on the top. You got the solubility rules in the middle. We'll talk about strong acids and strong bases next time, but those are actually pretty easy. You just got to kind of memorize them, okay? So those are the things that you should be looking at and working on. You still got over a month to do it, and believe me, I've been doing this for a long time. People do very well on this stuff, okay? So again, those are your solubility rules, and as I showed you before, that's the SO4. So if you just memorize nitrates, you memorize that alkali metals are soluble, and all halogens, these are halogens, except for Ag and Pb. Mercury really doesn't come into play. If you just memorize those 3, that's about 80 to 85% of all things that you're going to need to know. So I think that's a pretty good deal. All right. I was trying to do the answers. So, okay, let's go. So on your note sheet, I have 1 mole. Unfortunately, the top part did not work out really well, so this is a really important part in your book. I just want to reiterate. I think a lot of you know this stuff already, so you might have to fix this on the top, or you're writing on just a note sheet. But reminder on each side here, 1 mole on a periodic table equals how much it weighs on a periodic table, and that mass is that many particles. That's it. So I always envision a periodic table as a box or a bag, and it's holding that many particles, and it just happens to weigh 16 grams or 46 grams or whatever. So let me just give you 2 examples, because we'll jump right into this stuff today. 1 mole of silver. What does that mean? It means that if you had a mole of silver, it would weigh 107.9 grams. And how many particles would I have? Oh, look at that. You'd have that many particles of silver, because 1 mole is like a dozen, but in this case, it's a lot larger. If you had a compound, same idea. 1 mole would be the Na and the Cl, so that's 58.45. How many particles would that be? Well, particles is generic. That would actually be molecules this time, but it'd be the same number of particles. So whenever we say a mole, it's always the mass. Whenever we say mole, it's always particles, of which is Avogadro's number. So if you don't get it yet, if you couldn't explain why it's like that, you still can do all this stuff. It took me a while to really, really be able to feel like I had it to a certain level. So let's talk about what you need to do for your chapter. Molar mass. In AP Chemistry, you never have to show this work after this chapter, but you should be able to do it. So ammonium sulfate, if I ask that to you, what formula is that? How close could you get right now? Could you write that out? Could you actually figure that out? How close? So it's 2 polyatomic ions. This is really important. This is why we're learning this. We got to crisscross stuff. So ammonium is NH4 with a plus. Sulfate's SO4 2 minus. So the 2 is going to come down. So it should look like that. So then what do? I add them up. So how many different elements do I have? 1, 2, 3, 4. I have 2 N's times 14 is 28, right? So nitrogen's bringing 28 grams. If you're like, this is really basic stuff, that's fine. Some of us may not remember it. That's why we go through this stuff, so we don't have to spend any time in September. I have 4 hydrogens in here, but there's 2 of them out here as a compound. There's a polyatomic ion, so that means I have 8. So I have 8 grams coming from my hydrogen because it weighs 1 gram. I have 1 sulfur. That 4 does not talk about that sulfur. So 1 sulfur is 32.06. If you did 32.1, congratulations, you can round. That's awesome. Still fine. And then you have 4 oxygens. So 4 O's times 16 gives you 64 grams. Add them all up, and you get 132.06 grams per mole. And that's how that works. So, molar mass, to be honest, I just punch it in a calculator. I don't really show it ever. If it's asking you to show it, show it. If it's not asking you to show it, it's fine. Just punch it in. So I would have done 2 times 14 plus 8 plus 32.06 plus 4 times 16. Enter. I get 132.06. All right. There's 4, I think, big things in your chapter. So the second one, percent composition. Every year people are like, I don't understand what they're asking for. It's not that hard, but you got to see it. So aluminum carbonate. What would that formula look like? Okay, I got on my aluminum. What is carbonate? We just did it. It's CO3 2 minus. So I'd have to look on a periodic table. Aluminum's 3 plus. I crisscross. So it's an Al2 CO3 3. Okay, so it's 234 grams per mole. Where did I get that? 2 times 27 plus 3 times 12 plus 9 times 16 is that. Why did I do that? Because I want percent composition, not molar mass. So now what I'm doing is basically just saying the percentage of each element. Let me give you an example. 2 times 27 is 54. Divided by 234 of that compound by mass, Aluminum is 23.1% of aluminum carbonate. Carbon, 3 times 1, so I got 3 times 12 total. It's 36 divided by 234, 15.4%. Technically, I could now, because I have 1 element left, 100 minus those, but I'll show the work. 90, 9 times 16 is 90, divided by 234, 61.5. And that should equal 100%. So that's how that one works. Unfortunately, the next one we have to do
what we do here is
on here again, so give me a second. All right, again, questions, let me know. I'm not even sure if I'm connected to people anymore. Very, very weird. All right, we're gonna do a different one. I gotta stop again. Hey, you're still there, I think. Okay, so this one, it's one of the last things, well, not the last things, we did this a long time ago. This looks like the plane crash activity. So why not talk about cocaine? All right, so let me know if you can't see this screen. It should say cocaine on it right now. All right, so I'm not encouraging drug use. What is the formula of cocaine if you were given percentages? So in a movie, a lot of times, you know, they're always analyzing like a meteorite and they give you percentages of something and they just know. If you assume there's 100 grams, then each of these could become, if the sample was 100 grams, then each of these percentages becomes grams. So what I'm gonna do is basically say, you should be seeing me writing right now, I hope you are. Is that, oh geez, okay, that's not the right pen. Let's do this. There we go. Is that I'm gonna turn each of these, you might remember this, into a little T-chart. It's not that complicated. When I say T-chart, your brain should not be spinning around in your head and freaking out. It's okay. So then I say 1 mole. What I'm gonna do is anytime in science and chemistry, when you have to compare something to something else, you can only compare with moles. If you don't get that, I guess for now, just believe me. Like, oh, I gotta compare one to the other. I gotta compare with moles. Or else it's like apples and oranges. You're not comparing with the right units. So what I'm gonna do, this should look familiar now. You're like, oh yeah. So I'm gonna use my handy dandy calculator on my phone. And I'm gonna calculate this stuff. Don't round too much. Those are moles. Oops. That's a mole. 4.62. Now I'll round it there. All right, I don't know if you remember what you do, but those are all comparing each other. I don't know about you, but I really don't know how many, like when I compare these two, like how many 0.3298s are in 6.98. It doesn't jump out perfectly to me, and you shouldn't have to do that work anyway like that. So if you remember, what we do is we divide it by the smallest value to get whole numbers. So what I'm basically doing is just dividing it all by 0.3298. So I do 5.604 divided by 0.3298, and I get roughly 17. This is about 21. This one's a little bit of a stretch. This is about 21. I got to cheat a little bit on that one because I didn't do 1.01. I should have done 1.01. This has got to be 1. Oh, jeez. That's about 4. So what's my formula? Well, these all go right in there. C17H21. NO4. Cocaine. That's that. So that is definitely the plane crash activity, if you remember that at all. I'm just taking a picture of these all here. Okay, let's go to the next page. I'm going to stay right on here. Balancing equations. Again, this should be on your note sheet. if you don't have your note sheet, sorry, you should be able to write on an equation. So writing out formulas. So I have the whole thing already written out. Like, can you execute words into formulas? That's basically what this one is, okay? So I have phosphorus. If I ever give you a formula, please don't fight it. Go with it. So it says reacts with. So again, don't overthink this stuff. Reacts with. Okay, potassium chlorate. Got to make some compounds here. So potassium's K. Chlorate is ClO. Gosh, what is it? ClO. I got to think about what that is. It's a 3 with a -1. Every time I make a new compound, it's be a plus and O. Those are good, right? To produce potassium chloride, KCl. And, oh, prefixes, easy peasy. Phosphorus, di. Oxide, penta. And there it is. Now I gotta balance it. And sometimes you can't go too quick. So let's talk about that for a second. If I go, oh, there's 4, and I put a 4, don't do what I'm doing. And then I go 4 times 5, oh, that's 20, and then I get right here for oxygen, oh, that doesn't equal 20. So sometimes what you gotta do is just take a step back and see if there's some sort of a number that doesn't match up. And I didn't do this beforehand, so I might be wrong on this, so let's find out. So 3 and 5 is 15. So let's try to make that 15. So I'm gonna put a 5 here. I don't think this is gonna work still. And let's see why. So that's those equal, but now what did I just do? I have phosphorus of 6, and this is only 4. So when you get stuck, suggestion, I'm not making you do this in AP, but you could list, I don't know if you remember this from Chem, we listed it, right? And then you write them down on the side, and you say you have 4, and you have 2, and you have, oops, the 5's not there yet. You have 1, and you have 1, 1, 1, 3, 5. Here's the issue. One of these is going to be a problem. So the 3 and the 5, it didn't work because then the phosphorus didn't equal. So you got to keep amping it up. That's my biggest trick to you. Find the thing that's in the way and just keep making it bigger. So if 3 and 5 did not make 15, it didn't work. Let's go up another level. So the next time they're going to meet is 30. This is one of the hardest ones to actually balance. This was actually on a balancing sheet you guys did a long time ago. So if I put a 10 here, I make 30, I make 10, I make 10. And now what? Well, I need to do a 10 here. And this is 12. Oh, 3 times 4 is 12. And now I'm done. So it's a 3, 10, 10, and a 6. Honestly, the balancing is as important. There is hardly ever a problem in AP chemistry where you're like, I can't balance this. If you can't balance it, you probably made the formula wrong, not the balancing issue. So we'll work on it. We'll work on it. That's why I'm having you work on polyatomic ions. Okay? So again, please ask me things if you need to on that. All right, we're going to jump in. I think I'm done with this, my tablet. Yes, I am. Okay. We are off to the final parts. We're going to take our time on this. So I'm going to need to know if you guys are like done or if you want to work ahead. And again, if you don't have your note sheet, I'm not sure how I'm going to know, or you're going to know what's up next. All right, so if you guys remember this is a horrible layout. I'm sorry. It's the best I could do on this. Usually, again, I draw this out, is that you need to know this flow chart, right? Like that should not be a huge leap for you, right? You have moles in the middle, we have grams and particles and liters, right? When we're moving through it, we're gonna practice this a lot. I don't expect that you feel or have to feel like you have it down immediately in every scenario. I'm gonna be here, I'm gonna help you out with it. But just remember that. It's moles, grams, particles, liters. If you're freaking out about the whole STP thing, it's supposed to be 22.4 liters at STP. We're not even talking about that today. That's in a normal chapter. So here we go. I have 3 problems on the back or the second sheet of your note sheet. And there's story problems. And I want to kind of go through each one of them with you quickly here, okay? So I'm going to do the first one totally verbally. I'm just going to go. And next to you can work on your own with me. So it says solid lithium hydroxide is used in space vehicles to remove exhaled carbon dioxide from the living environment by forming solid lithium carbonate in liquid water. What mass of gaseous carbon dioxide can be absorbed by 1.25 kilograms of lithium hydroxide? Woo! Those of you that sit and go, oh God, slow down. What do we always need first? you need a formula. In chemistry, the formula is the picture that says 1,000 words. The formula is the key. And when I say formula, I mean products and reactants. Okay, so let's just take a breath. It says solid lithium hydroxide is used to remove carbon dioxide. So I have to have LiOH and CO2. It says forming solid lithium carbonate. So that's going to be a product, and liquid water. Okay, so this is my formula. Let's talk about that again. Lithium hydroxide is used to remove carbon dioxide. When they react, they combine together and they're consumed. To remove is to consume. Okay? It says to form solid liquid lithium carbonate and water. So there's my formula. Sometimes you'll be given the formula and it doesn't even matter. All right, organize your information. What do I know? I know I have 100 or 1.25 kilograms of that. And it says what mass of carbon dioxide. Okay, so all I'm doing, you guys, is going from LiOH to CO2. If you're looking at the flow chart, I have just totally dismantled the difficulty. I'm going from grams. I'm going to go back here. I'm going from grams. If you can see my controller or my mouse, grams of one thing to grams of another. That's 1, 2, 3 steps. That's it. Okay. So, whoops. So, the only issue here is I'm in kilograms. So remember that a kilo means 1,000. So you could just move that decimal place 3 times to the right. And I'm going to show this all to you now because I unfortunately couldn't get this to go step by step today, and I'm sorry, but let's talk about what you see. So you don't need to put this in here like that. You could have just started with 1,250 grams of LiOH. But then again, what am I doing? I'm converting to moles, right? I'm doing the mole ratio, 1/2, and then I'm going back to grams of the other compound, which is 44. And that's it. I don't have an answer. We can do it right now. I will do it right now. And I got 1,149 if I round up. And that would be grams of a CO2. Okay? So that's how you would just do, to me, a very complicated sounding problem, but not as complicated as it seems. So I'm going to give you a moment, and you're going to work on the next one. So if you don't have your sheet, you can still write on a sheet. If you have nothing to write on, go get something to write on. All right, I'm going to help you out in the beginning. So it says nitrogen gas can be prepared by passing gaseous ammonia. Ammonia over solid copper 2 oxide at high temperatures. The other products of the reaction are solid copper and water vapor. If a sample containing 18.1 grams of NH3 is reacted with 90.4 grams of COU, which is the limiting reactant, how many grams of N2 will be formed? So I will get you started on this. What is my equation? So it says nitrogen gas can be prepared. Being prepared, that's like I'm going to prepare a meal. So I got to use recipes to make something at the end. So that's going to be a product. Okay, so I'm probably taking my copper 2 oxide. 2 means +2. Oxygen is -2. And I'm reacting it with ammonia, which I don't expect you to know what that is yet. That's NH3. It says the other products are copper and water vapor. So this is what it looks like. I take my ammonia. Don't expect that you have this all down. Just kind of relearn this stuff. And I'm reacting it with the copper 2 oxide. I made nitrogen gas. I made copper. And I made water. And then I just balanced it. Right. Let's talk about what we have. It says I have 18.1 grams of ammonia. And I have 90.4 grams of CuO. And it says how many grams of N2 will I make? So, you don't need to answer the first question first. You can answer it last. It says, what is the limiting reactant? So I don't know if you remember this, but you need to do 2 T-charts. So you're going to do a T-chart from ammonia to nitrogen, and then you're going to do another T-chart from CuO to nitrogen. and then we take the smallest answer. So give it a shot. I can't hit next because if I do, you'll see everything. So I'm gonna give you a minute or two. I'll give you actually 3 or 4 minutes. Try to calculate this, please. It's really important. Then you'll have a good example. Okay? Again, shout out at questions if you have any. Even good to know if you're still there. Oh, we could play like hide and go seek when kids were younger. You'd be like, do I hear a cow? And then you hear a moo, or like a rooster. So you're doing 2 T-charts. Each one will be 3 steps. Oh no. Can you see it now? Bailey, can you see it now? Hello? Oh. Can anybody else not see it? Hello? So wait, have you not seen any of the presentation? Okay, hold on. Can you see it now? The heck, I hate Google Meet. All right, here, let me go back. Now I stopped it, so we'll do it this way. Okay. Okay. Can you now, hold on. Can you see it again? Okay. Let me know if you can't. But I'm doing it in a different way. I don't like this way because now I can't see I only see a PowerPoint, so I can't see anything. I feel like I'm talking to a computer. Let's hope this is not like the fall. I will get this down. I'm going to steal my smartboard. That's what I'm going to do. I'm going to mount it in my house. My wife will love it. I seriously might steal it. If you are getting stuck, I'm going to give you one of them. So that's what the first one would have looked like for me. So I would have done my ammonia. I divided by what ammonia weighs. I do my molar mass, my mole ratio, and then I multiply it by the mass of nitrogen. What's awesome about this, you guys, is that the second one, the second half is the exact same. Anything with N2, exactly the same. You just plug it right back in. What's different, you take out the NH3 and you got to put in CuO. So, oh my God, off the top of my head, I can't even remember what copper weighs. Don't tell me. 63.8, maybe. I will look. Oh, that's close. 60, I can't read. 63.5 plus 16. So that's what you're going to have on that. So that's what I had for the second one. If you are slightly off with your molar masses, give yourself a break. We all round differently. It's okay. I don't have answers, but I'm going to quickly do it again. So this is where, unfortunately, some of us don't finish, and you write everything except this. So I got 14.9 on the top one, and 10.56 or 10.6, let's say, for the bottom one. So it's 14.9 for the top and 10.6 for the bottom one. What's my final answer? 10.6. Better question, what is the limiting reactant? If you would write limiting reactant right here, you would not get the points. And usually they don't care about the answer. They want to know the limiting reactant because that's what matters in industry and everything else, like what's going to run out. The answer is CuO. This right here makes only 10.6 grams, so that's my limiting reactant. The limiting reactant has to be a reactant. So the CuO, I usually write LR, or I'd write CuO is LR, capital LR. If you remember that from class, that means the limiting reactant. Okay, so I know it seems like you're doing two T-charts, but I guess I try to look at it as I'm not really doing a full two T-charts. I'm kind of doing a T-chart and a half. Okay? All right, we only have one more problem left, and that's it, folks. So hopefully you still can see this. Oh my gosh, it's so long. Okay, let's just talk about what we see. So it says methanol is the simplest alcohol. It is used as a fuel in race cars and is a potential replacement for gasoline. Methanol can be manufactured by a combination of carbon monoxide and hydrogen. Suppose you have 68.5 kilograms, let's call it 68,500 grams, make it easier, is reacted with 8,600 grams of hydrogen. Calculate the theoretical yield of methanol. Is 3.57 times 10 to the fourth, so just move the decimal four times over, is actually produced. What is the percent yield? What? Okay. I purposely made this confusing. How do I eliminate confusion? Because this is what's going to happen. You're going to read something and be like, I have no idea what they're going to do. Every time I get stuck on a problem, I always write down the equation first. So this is the equation. And you're like, no, that was the equation. It's CO. It's if you just reread it, you'll see it. It's the combination of carbon monoxide and hydrogen. And you're like, how did you know it was H2? It's a diatomic, heck no halogens, or it actually gave you a hint right here. And then it just says it makes methanol. So now let's organize our information, because that's confusing. So I have 68.5 kilograms of CO. Again, honestly, guys, I'm trying to make this harder than it probably really will be, because if you're understanding this, you're going to understand simpler stuff. You have 8.6 kilograms of this. Reminder, just multiply it by 1,000, so just move it over. So 68,000, 8,600. And then I want to know percent. Okay, this is from last year, or whenever you took chem. So what is the percent yield? Oh, gosh. Percent yield is how much you made over how much you should make. Okay? The bottom is the theoretical yield. That is always a T-chart. You always have to solve the bottom with a T-chart. So if I'm asking for percent, that means that I have to be given the top. And that's right here, you guys. The 3.57 times 10 to the fourth. Right? Or 35,700 grams of methanol. So what you're going to do is you're going to do what? Two T-charts. I'll show you one. Right? I'm going to find out how much. If I do two T-charts, I take the smallest answer, and that's going to go on the bottom, and I'm going to take this number, and I'm going to divide it over my answer. So I know I just kind of disarm that problem a little bit, but see if you can do it. So now I'll do the hydrogen one. Do a second T-chart, and find how many grams of CH3OH you make. And then think about what I just said. Can you find the percent yield, or how much was actually produced percentage-wise? I'm going to give you a couple minutes. Shout out questions if you have them. Like, how did I also get so bad at working with my computer and iPad? All right, so I'm not trying to cut you off if you're not done with it yet. That was my second one. Again, if you're looking at that beginning part and you said you didn't, I thought I didn't have to show the kilogram part. You don't. You could just simply put that in there. But I don't know the answers. Please, okay. Oh wait, Okay, I don't have an answer right now, but we can calculate that. What is up with me and not having answers today? So this is the actual yield, okay? And then I'm going to take the smallest answer. I'm going to plug it in underneath that, though. So 68. So that, oh boy. Top one is 78,285 or 286. 78,286. 78,286. 78,286. 78. I can't remember. Just let's hope that's not that one. Wait, was the first one 78,000 something? I think it was. Well, this one's 68,800. I'm going to assume that's the one. Hilarious. Okay, I don't even know if I just plugged the numbers in right. I think I put 68,800 from the second T-chart on the bottom, which then gives me about 51.9%. Please tell me if I'm totally wrong. I can't even remember what I just typed in. I don't know. Yes? Okay. I'm going to assume your silence is a resounding, you're amazing, Mr. Gussie. God, your chemistry is awesome. Off the charts. So, guys, please get this. I'm going to go all the way back. Sorry if you want me to show you that sheet again in a second. Get this printed. Get that printed. Start making note cards. I don't care if, well, I do care a lot if we somehow aren't in and are doing virtual, but we're still having some sort of a quiz somehow. Like, you're going to have to know it, okay? You're going to have to know polyatomic ions. You're going to have to know solubility rules. And you're going to have to know how to do the strong acids and the strong bases, okay? So, that being said, I guess I don't have a ton of time. I can't stay that long after today like I did the other day, but if anybody has any questions, let me know. Try to finish up chapter 2 by this month. So whatever we have about a week left, right? And then we get into chapter 3. We have only 2 more sessions left. Chapter 4 stuff's really important, really important. It's new stuff, guys. So that's really important to come and see, or at least watch the videos in some way, okay? So if you have any questions or want to see another slide, or for me to go back, let me know. It was good seeing your letters with a muted microphone next to it. It was great. It's good to see that. So let me know if you need anything, okay? Or else have a wonderful weekend and wonderful upcoming week.